So in this video, I'm going to go over the solution to the example 7 from our 12.1 lesson notes. Now, this is just like example 6 and example 5, where we are being asked to describe a set of points that is described by an inequality rather than just an equation. And the way we want to begin is the same, in the sense that we want to think about, well, what would it mean if this was an equality? And then we can go back and use the inequality to make a decision about which parts of the regions should be shaded on our graph. So I'm going to begin by taking y squared plus z squared and setting it equal to 4. And I notice that this is an equation that only has two variables in it. And if you recall from a previous example in this lesson, we looked at things like x plus y equals 1, or y equals x squared, or z equals x squared. And what we said we can do when there's a variable missing from the equation, we know what's going to happen is you're going to draw this as if you are in that two variable plane for the two variables that are present. And when you move it to 3D space, you're then going to stretch it into what we call a cylinder along the x-axis, or in this or the variable that is not part of the equation. So it's going to be helpful for us to first draw this in the YZ plane, because those are the two variables present in my equation. And recall that in the YZ plane, the standard orientation is to have Z pointing upward. It's the vertical axis, and Y is the horizontal axis. When I look at this equation, you might think, oh, this looks like a circle. We're used to seeing something like x squared plus y squared equals 4, and that's a circle of radius 2 centered at the origin. It's the same type of thing here, it's just that our variables are y and z. And so I'm going to draw a circle of radius 2, and I'm going to center it at the origin. And then this is what I'm expecting to see in the YZ plane. So if I was going to transport this over into 3D space, I could duplicate it and actually just slide it right on over, because the YZ plane is what I'm looking at dead on in my system, in my 3D system. So I have now drawn that in here, and what we said we do next is, because there is no x in this equation, we know that this is going to be slid backwards and forwards along my x-axis. And we're going to end up with something that looks like a cylinder laying down on the x-axis. Now, before I do that, I'm going to come over here and notice that this is saying that my inequality is strict. So whatever I am doing, even though I've spent all this time getting to understand this circular cylinder that I need to use to bound my region, that circular cylinder is not actually going to be included. So you're going to exclude the boundary of the circular cylinder. And the reason why I'm thinking about that right now is just because what I want to do is change this to a dotted circle, so that when I am sliding my cylinder, I'm always going to be using dashed features to identify my surface, because it's not actually included in my inequality. So now I'm going to take this, I'm going to duplicate it, I'm going to slide parallel to the x-axis here, forward and backward, and then I am going to connect these using lines that are parallel to the x-axis. Now, it's important that when you make your connections, you also use dashed lines, because those are not included. Remember, the surface is not included because the inequality is strict. So now I have this, and now I have the base shape that is creating the boundary for what my region actually is. Let me fix that a little bit, that looks kind of crappy. Okay, so now I come back and I say, okay, well, where do I shade? Y squared plus z squared has to be strictly less than 4. If I think about what that would look like on my picture over in the YZ plane picture, it would mean that I'm either going to be working with circles that have a radius at, getting closer and closer to 2, or it's going to be smaller. So I'm going to be shading inside. That tells me that when I come over here to my surface, if I want to make sure that I am capturing y squared plus z squared being strictly less than 4, the set of all the points that satisfy the inequality are inside. And so I shade inside. And now that is my region, and I just need to write a description of the points that satisfy this equation. So I'm going to go ahead and say description, and I'll say the region is the set of all points, and I'm going to say strictly inside to indicate that I am not including the boundary of this cylinder, strictly inside the circular cylinder. And I'm going to say that it's along the x-axis to indicate that it's been stretched along the variable that was missing, and centered at the origin with radius 2. Anytime you have a circle in play, you should describe where it is centered and what its radius is. And if you have a cylinder, you should describe what axis it lies along in your description, just to be clear. And again, this strictly inside, that corresponds to the fact that I was not including the boundary because this was a strictly less than 4 inequality. And that's the solution.